Hi, welcome back. This is supposed to be lecture 7 because after you can say, posted lecture 7, I found that you might be having a doubt how to fix a frame arrangement and all, in specific, how to choose x-axis and what norm or what you can say procedure you have to follow. So, in order to get it a little more clear, I am taking this as a lecture 8. So in this case, I will be showing 4 different cases. In fact, actually like more than 4 cases. It is something like a 4 major cases. Inside that there are some subclasses are there. So I'll be showing like what are the different configurations we can see and how that can be actually like addressed, in the sense how we can actually like get the frame arrangement. So if that is the case, we will move forward. So this particular lecture we would be talking about, this is not really required because this particular slide set is actually like purely based on my own. But these are the cases. So we would be recapping what is frame arrangement and how we can choose x-axis and what's supposed to be z-axis and all. Then we will actually come back with this x-axis and we will be seeing 4 different major cases. Okay, this is what the case. So let us start the very first beginning. So we will actually like recap what the frame arrangement all about. So like if we use a non-standard method, you have n-axis, you can say manipulator, you would be having n plus 2 frames. So this is one thing. And second thing is like z-axis is actually like associated with the joint and the x-axis associated with the link, and z-axis straightforward, we can easily fix it once you know the manipulator configuration, and then you can actually like fix it. But whereas the x-axis is purely depend on you can see 2 frames. For example, xi minus 1 is actually like depend on zi minus 1 and zi. In the sense, this current x-axis is actually like depend on, you can say, current x-axis depend on current z-axis, and as well as you can say proceeding z-axis. So that is what the case. So you can see this is what we have mentioned. So the joint axis are assigned to z-axis to the corresponding you can say coordinate frame. And you can see second one is the fixing frame location is based on where the intersecting of you can say z and x axis, that is what we are thinking about. So for that we will be drawing the common normal between, you can say, zi minus 1 and zi. So then we will make it. If that is not really happening, then what is the protocol? That is what we are going to see. So in the sense, you can see that if it is intersecting, then you can directly put the intersecting point as the frame location. But if this is not actually like intersecting, then how we will choose? Some cases neither intersecting nor parallel, then how we will do it, that we will see little later. Right now this is the broad case. Okay, so now further what we have seen, that the x-axis fixing is actually like based on the current z-axis and the proceeding z-axis. So in the sense, if these two are actually like consist of in one plane, so normal to that plane would be, you call this is zi and zi plus 1, and this is what the xi plus 1. So this positive xi plus 1 is based on the, you can say, progressing side, in the sense the link length. So we know like the link length we have written as a cannot be, you can say, negative, in the sense it can be greater than 0 or equal to 0. That is what the case. So now this is what I mentioned. Now we will go the specific examples. So in order to get the specific example, you can see like I have taken random z1, and the next one is actually like you can see random z2. But now z1 and z2 is actually like associated with the link 1. And how we will actually like choose x-axis? Since these two are parallel, you can see that the common normal can be drawn infinite, right? So in the sense, how we will actually like go forward? So we'll actually like take, this is the point, and then we will actually like connect the common normal. In the sense, I can actually like choose this, and you can actually like take it, and this is what your x-axis. So this is what x1. So this is what I am actually like doing it. You can see this is what x1. So this is very straightforward, easy to do it. Now we'll move little forward. So I'm just taking this, but z1 or z2 are actually like not this one. In the sense, it is having two displacement. So one can be represented in x, another can be represented in y. So in the sense, you can straightforward, you can choose this as x1, and this would be like a d2, and this would be a, you can say, in the case it is actually like a1, because 2 minus this one. Okay, so that is what travel along you call in the sense, it's supposed to be, you can say, travel along x1 to x2. That is what, in the sense, along this direction. Okay, so these are actually like you have seen, and we'll actually like see this is straightforward because these two axes are actually like parallel, right? So now we'll see one specific case where this is actually like slightly offset. So in the sense you have Z2 here, what you can do it. So in that sense you can see that there are three distance how we will address. That is what the next case. Okay. So the next case is actually like straightforward. You have seen that now the Z1 and Z2 are actually like not straightforward. It is actually like parallel, but there is no vertical displacement. Now what you can see, earlier we have seen that the common normal we have drawn parallel to like this, but now the common normal you have to draw like this. So in the sense I call this is distance x and y. So this is the square root of x squared plus y squared. This is what your a distance, and this is the axis of x. So in the sense, so you can see like I am drawing the common normal between these two. Okay, and I am actually like fixing my x-axis along that. It is true, right? So this is what we have seen. So now even you go little forward. So I am saying that this x2 axis is actually like offset here. So then what we can do, the same procedure, you just make a common normal. So the common normal direction you fix x1, and this would be come in joint distance, and this is coming as a link length. Okay, so this is what we are actually like doing. These cases are actually like straightforward, right? In fact, actually like these two sub cases are actually like case 1 and case 2 are very straightforward because you have a common normal and you have done, right? So now we will actually like go little forward. So little forward in the sense we go Z1 and Z2 are actually like non-parallel. Okay, so in this case you can see that these two are intersecting. So now you can see that the intersecting point you can take as 1, that is straightforward. But now you can see that which plane these two axes are actually like associated, this plane. So now in that case what would be the x-axis direction? So x-axis direction is normal to this plane, either pointing inward or pointing outward. So I am taking actually like pointing inward. There is nothing wrong because there is nothing defined the progressing side. I can choose either side, but I am taking as actually like going forward. Okay, it is going inside the this iPad. So this is one case you have chosen, and you can see then this distance is belongs to joint distance, right? The same thing, it is actually like slightly offset. So in the sense slightly offset in the sense you have Z1 and Z2 are actually like offset. In the sense it has actually like longitudinal direction and as well as lateral distance, how we can address. So here also you can see that the plane consists of this is actually like the plane parallel to the screen, and in that sense the x-axis is supposed to be piercing the screen either inside or outside, right? So in the sense you can see that your x-axis is supposed to be either inward or outward. I am taking the inward one. So this is the case, right? It is straightforward to choose x1 and all. So now the similar direction we are going little forward. So but you can see that here it is actually like normal this direction. Now this normal is here. What will happen? That is what the next case. You can see that Z1 and Z2 are, you can say, non-parallel. It is orthogonal each other. But here you can see that neither intersecting, right, nor parallel, right? Because Z1 and Z2 are not intersecting, but in this case it intersecting, but it is in this case it is not intersecting. But which plane it is consist of? So which plane it is consist of? This plane is actually like you can see. So I can actually like replace this. So this is the plane where you can see that the Z1 and Z2 can be superimposed. So in that case, which axis, like which side or which direction or which axis the x-axis supposed to come? It's supposed to pierce inside or outside. And you know here the progressing side, this is 1 and this is 2. So this is what your x-axis direction, right? So this is the way we can choose. And now since this x-axis we have chosen, so the intersecting point I took 1 and here actually like I took 2. So similar direction, this is actually like slightly offset. So what will happen? So slightly offset, still you can see that the same case we can actually like see. So this is the plane and this is the normal direction, this is x1, and the sense this is the direction of A and this is the direction of D, right? So I can do that and I can actually like get it. So these are actually like straightforward cases where you can actually like somehow you can actually like bring all three distances You can say even if the position are actually like z1 and z2 are having even position of three quantities, in the sense x, y, z all are there, still you can see that it can be done with a common normal and then you can do it, right? But now some cases which will not able to do that way. So what the case? You can see the example. So this is actually like straightforward. You can see the z2 direction, this can be incorporated, but this direction is actually like z1. So this cannot be definitely portrayed along x. So then what we can do? So what is the normal direction of this two axis consist? So either it goes inside or outside. So x1 I can do. So if I choose x1, that is by default you have already chosen x1, but you can see that if I choose x1 in this direction, so I cannot accommodate this distance, right? So then what I supposed to do? I have to do something else. So what that mean? So I have to actually like see, so I have to see something like I have to make, okay, so I have to make something which is a virtual frame. In the sense I have to choose a frame here. So in the sense I can actually like choose a frame here or here, I have to choose. So why that way? I can actually like make a frame straightforward here. I can choose this is virtual frame 1 to 2. Okay. So now what it says, this distance is covered as a joint distance here 1 to 2, and I can still choose x2 1 to 2 like this. You can see in that case what I am doing it. I am actually like achieve this missing distance here. The same thing I can go further. Okay. So even this is actually like offset in x-axis. So then you can see what happening. So now you can see that this is what I am doing. So now I am taking a virtual frame here, that is 1 to 2, and this is actually like my 2 and this is my 1. So what I can choose, so I can see there is a frame virtually I am choosing, that is z1 to 2. So z1 and 2 are parallel, so I can choose x1 in this direction. So x1 and x1 to 2, because this is intersecting, right? So I can use this case. So now in that case what happened, this distance is actually like covered as d2 and this distance covered as a1, right? So this is covered as d1 to 2. So like that we can actually like incorporate but you can see already the limitation of DH parameter. Although you have physically two frame, so but you are actually like intervening or introducing a virtual frame, right? If you are not introducing virtual frame, you cannot accommodate as per the general Danavit-Attenborough, right? Otherwise what you have to do, you have to assume that this is actually like x-axis, or you have to actually like make it some arrangement, but even you make it, the physical interpretation is not coming, right? So that is what main case. So then we will go the slightly the same direction with another, you can say, complexity, where you can see z1 and z2 are actually like neither intersecting, non-parallel, but you can see here what you can see, this distance is actually like not going to cover by anyone, but you can say this distance is also like not straightforward to cover. So then what you can see, when I fix x-axis, you know, like this is the plane. So obviously this distance somehow I can cover with x, in the sense that can become as a link length. But what happened to this? So this cannot be done, right? So in that sense what I have to do, I have to actually like make a virtual frame here. Okay, already I have 1. Okay, so this is 2 and this is 1. But what I am trying to do, I am creating a virtual frame here 1 comma 2. Okay, I am taking that as z1 comma 2. Then this distance is coming with a virtual frame, because this is your, you call x1 direction, and I am choosing this is x1 comma 2. Then you can see that this distance is coming along with that. The same way I can go further. What that mean, I can actually like go further, the same thing as here, and this distance is covered with this z2, but the other distance is not coming. In the sense I can take this is 1 and this is 2, and I am actually like taking as some virtual frame here 1 to 2. The sense I am choosing this is actually like z1 2, and I am just taking this is x1, and in this case this is x1 comma 2. You can see that this distance is coming to this as a joint link length, and this is as coming as a joint distance, and this is coming as a joint distance. So this is a way we can actually like do you can say complex frame arrangement. Now you go back, okay, and you see lecture 7, you can easily understood why we have chosen all the frame such a way that, okay. So now I hope you got a clarity how we can actually like fix the frame and how you can choose x-axis and how you can actually like make you can say use of all the information. And you can actually like clearly see, even I choose a virtual frame, but everything you can see that the alpha is multiples of 90, right? So these all actually like you can see here. So these are actually like one set of you can say frame arrangement. In fact, I supposed to call this as a discussion, but since this week I have to cover few lectures, so I am taking this as a lecture 8, and probably I will post the next lecture with forward kinematics, and next lecture would be introduction to inverse kinematics, okay. And as I already mentioned, the positional vector, or you can say the transformation matrix, which is actually like A transformation matrix of B with respect to A, I can write as position vector and rotation matrix, and this position vector is actually like major. So in the sense you can see you choose anything for your position, the first 3 axes predominantly defining. So in that sense, this 3 are actually like coming back with you call the major axis, which are actually like 1, 2, 3 of your joint axis, okay. So then the next 3 axes 4 to 6 is actually like predominantly is delaying, or you can say playing on the orientation role. So then it is called minor axis. So why it is called major and minor axis? If you see in the conventional manipulator, the first 3 axes are actually like defining the position, the next 3 axes as a spherical joint, which is going to define your orientation. So this is what we call minor, and this is what you call major. So then whatever excess in the sense 7 to n axis, that is what you call redundant axis, okay. So these all actually like we would be seeing in the next lecture, but I'm just giving a small introduction here. So in the sense you got a clarity now. So what exactly the frame arrangement, how we can do it, and how we can move forward. Whether you are using a standard or non-standard, this is the way you have to fix your frame. So after that you can choose your DH parameter according to your standard form or non-standard form, okay. So with that, I'm actually like closing this session, and we can actually like see or meet on Tuesday morning, or you can say afternoon in this class, or in this week it is afternoon, okay. Thank you, bye bye, take care.